Alright, this is Spencer and I's proof of the Pythagorean Theorem. So the first thing we're going to look at is these two squares. This one has side A and this one is side B. So obviously the overall area of each is A squared and B squared respectively. And that's just common knowledge. Alright, so now what we're going to do is we're going to take our two squares and we're going to pull them together. And once we do that, we'll be able to take these line segments over here that I made that will help make triangles. And the reason those line segments go to where they are to make the triangles is because, as you can see, that is side B right there. So that is side B, and that right there is still side A on this side. So as I was saying, this is still side A, and this is side B, so that means that this is A, and this is B, which also means that these two must be C. So then what we need to do to get to the next step of our proof is that we need to get rid of all these to get them out of the way. So we're going to still say that this is side C, and this is also side C. They're equal. What we're going to do is we're going to take this right here, this one right here, and we're going to pivot it around this point, and we're going to do it this way, which is clockwise. So then it's going to end up with we're going to pivot at 90 degrees. So then we're also going to do that to this point over here, this one over here, and we're actually going to pivot it counterclockwise, like that, around that point right there. So ultimately what is going to happen is we are going to get a square with side C, with one side being at about that angle right there and the other one like that. And those are both going to be C, and they're going to have the triangles inside. Once we do that, so we end up with the shape just about like this, and obviously it has side C all the way around. So obviously the overall area of this square has to be C squared. So that's how we got from A squared plus B squared equals C squared.
So we start off with four identical triangles with these sides A, B, and C, and since they're all similar, they all have the hypotenuse of C, and the area of each of these triangles is A, B over 2, and we can rearrange these triangles to make the square, make a square with sides. So there's our square. Here is the same square put together with all the sides are C, and so the area of this square would equal C squared, and the area of this little square inside is A minus B squared, and so the area of a triangle of each triangle is AB over 2, and so since there's four triangles, the area of the entire square is going to equal A minus B squared plus 4AB over 2. So we are going to FOIL this out, and it becomes A equals A squared minus 2AB plus B squared plus 2AB. And when we reduce that, it becomes A equals a squared plus b squared. And up here we said the area of this square is c squared, so we'll just plug that in right there, and we are going to get c squared equals a squared plus b squared. Yay!